Welcome to a lesson with Dr. Powell. This is part 2 of a description of plugging in like 0 plus and 0 minus into things. In the video we had ln, in part 1 we had ln of 0 plus. We saw that was equal to negative infinity. We also saw that the tangent of pi halves minus was equal to infinity, and things like that we talked about there. We also know that 1 over 0 plus is infinity, 1 over 0 minus is a negative infinity. So look at part 1 and some other videos that I have in the playlist for a description of these ideas. Realize and remember that these are really limit statements, what we're thinking of them as being plugins. They can kind of be useful sometimes. For instance, what if we were trying to compute a limit as x approaches, okay, so let's suppose we're taking a limit as x approaches negative infinity of the ln of 5 to the x. Now there's different ways you could think of change in base and change this up, but let's just look at it the way it is for a minute here. And we could use log properties. I mean, you can move this x out here to the front, and you can kind of really quickly see it's negative infinity. But let's look at it another way for a minute. The inside right here, 5 to the x, if we were to can we plug in 5 to the negative infinity? What is 5 to the negative infinity equal to? Well, if we take a look at the graph of 5 to the x, it looks like this, and its exponential decay in this way as x goes to negative infinity. And if we squash the number line, this would go to, so on the x-axis, this would be like the point at negative infinity. If we were to fill it in, notice what the y values that we get out is 0. In fact, it's 0 through positive values. We could think of that as being like 0 plus. Okay, so we could actually rewrite this limit as the ln of 0 plus. And we know the ln of 0 plus, which is a limit statement itself, is negative infinity. Now, you could have seen that simply, perhaps, just by going x ln of 5, right, using a property of natural logs, and then you would have seen the exact same thing. X is going to some negative infinity. Negative big times a constant number is going to be also negative big, or negative infinity. So that would be one way we could do that. Taking a look, we could also perhaps do something like, let's see, we could do something with, so we could do something like with tangent, and we can say, let's see, so we take tangent of, let's just say tangent of x, and then let's see, maybe we'll just do 1 over it, and then we can take the ln. So we're going to use ln again just for this description, and think about what happens as we take a limit as x approaches, let's see, pi halves from the left side. So as x approaches pi halves from the left side, you could just simply, let's just plug this in for x here using our descriptions up there. So what would we have? We'd have 1 over the tangent of pi halves minus, and then we plug that into the ln. Notice that tangent pi halves minus we could replace with infinity, so think of this as 1 over infinity ln. Now 1 over infinity, that's actually the same thing as 0 plus. and ln of 0 plus we know is negative infinity. So what we've just done is we've reduced taking certain one-sided limits to just the idea of plugging in, if we well-defined plugging in type actions like we did in the previous video. So a little description of that, and thanks for watching.